Good morning, ladies and gentlemen. I hope all of you doing well. So today I will present my work. It is about effect of cathodic materials on the degradation of organic pollutant on the efficacy of photoelectro-Fenton processes. So firstly, I will begin with the summary. We have firstly the problem and advanced oxidation process (POA). I will give you just a review about them and the result obtained, and finally conclusion. Problem of my work, it is the presence of organic effluent in industries such as the textile industry can pose a serious threat or a serious problem to the environment when they are discharged without a period. So the objective of this work, it is to study the efficacy of the nature of cathode materials on the efficacy of the photoelectro-Fenton processes. Different cathode materials will be tested according to their efficacies. First, we'll begin about the advanced oxidation process. So the term POA, it's refer of oxidation processes. It is all the type of oxidation processes. It characterized by a common use of OH point, hydroxyl radical. This hydroxyl radical, it is able to destroy complex and non-biodegradable organic compound, and they mineralize them to CO2 and H2O to mineral compounds and the final. So we have processes like ozonation, Fenton-like, photofenton, electrochemical processes, and photoelectro-Fenton. Of course, this is my method that I use it in this work because it has different advantages, like to destroy a difficult orient. I choose in this work methyl orange or methyl orange. It is a dye compound. So I tested about a methyl orange. So the firstly we have a comparison. This is the result obtained. First we have a comparison between the processes. So I use four different processes. Firstly I use just the light and the catalyzer. It is Fe, fer or the iron. So we have when I just use the catalyzer and the light EVA, I don't have any degradation like you can see. As you can see, the second one, just I use the light, so there is no degradation. But when I use the electro-Fenton process, degradation, it is almost it's almost 95%. And when I use the photo, the visible the UVA light with the photo with the electro-Fenton, the result, as you can see, it is almost 100%. So this is the of course this is the use of a light. Secondly, we have the effect of initial concentration of a methyl orange. So I just use for concentration 10 ppm, 20, 50, and 5 ppm. As you can see, when the concentration is decreased, the elimination of the pollutant is decreased. As you can see, we have for concentration. And the third one, we have the effect of the nature of the cathode, or the effect, the cathodic material. This is the main of our work. So as you can see, I have the CF, the carbon filter pristine or brute one, the non-modified, and we have two methods. I have the thermal one, CF 600, and we have MCF, M carbon filter. This is the chemical treatment. I just use two methods, thermal methods and the chemical methods. As you can see, there is a bit different of so when we modify the cathode, the percentage or the row is increase after the time. This is the methods or the work that I did. And finally, we have the conclusion. The POR are effective in removing a large number of organic pollutants, such as the methyl orange. They can be implemented as a single treatment, total mineralization, formation of less or non-toxic products. The porosity, the electroactive surface area, and hydrophilicity of the heat treated, the thermal modification carbon felt were higher than those of the raw carbon felt and the chemical treatment. Of course, when the modified carbon felt was applied of the mineralization of methyl orange by degradation of POF in acidic medium, a degradation rate of almost 99% was achieved. And thank you for your attention.